All right, yeah, nice. So got the introduction, brief overview. Yeah, I'll introduce myself. I'll provide some brief motivation for why we did this. It's a question I get semi-frequently, like every day. Talk about how we got here, the progression of Spack on Windows, our current state, features and packages, are we at parity? How do I even use this? And then I'll talk about our roadmap going into the future. Greg talked about Spack 1.0, so I'll be talking about Spack 1.0 on Windows, and then also a little bit beyond, kind of our 5-year plan for Windows. So yeah, I'm John Parent. I'm the Windows guy. Yeah, this is just a very Windows-esque presentation so far. Yeah, anyway, and we've been working this since the fall of 2021, which was basically my first project at Kitware. So why would we do this? Todd told me to. But the actual reason is the community needs it. So these are 2 issues that are, they're 4-digit issues, so they're pretty early in Spack's history. I think we're at what, like 5-6 digits at this point. The first one was filed in 2016. It was closed like 2 days later by Todd, who said Windows, this is Linux only at the moment because we use fork and symlinks, and Windows doesn't support either of those things, which is pretty much still true. It was reopened a little bit later once WSL was stable. WSL is still Linux, so we don't really call it Spack on Windows. That being said, it is a viable solution. Then it was reclosed in 2022 once we actually merged Windows support. And the real motivating issue was this Windows support issue filed in 2018. Basically requests native Windows support as opposed to any solution on Windows. A user had a requirement for explicit native Windows binaries, needed to build MSVC, et cetera. Just due to requirements from his users, or I forget exactly what. Basically, and there were a number of comments in that issue thread that said, we have not moved to Spack due to a lack of Windows support, right? So showing that there is definitely demand in the community. That's bizarre. Yeah, bizarre. Yeah, demand in the community for Windows support, right? It's hampering Spack adoption to some degree. What? Okay. Is it the doc? Is it the network? Doc? All right, okay, I will just read. So basically, someone had said, this is the last big missing feature from Spack. That was, I believe, the author of the final issue I had just discussed. And Spack, as without Windows, is not a truly cross-platform package management solution, right? You need Windows. As much as we all hate to admit it, and we don't like to develop for Windows, people need to do Windows. Not all of us are software engineers. Not all of us went to school for CS. Engineers exist, right? People who use MATLAB day to day exist. And so those people need support that doesn't involve like a deep knowledge of the Linux kernel, right? So we do need to support Windows. Even if there's just a couple users, maybe you're just doing your development on Windows and you're deploying on an HPC cluster, what have you, Spack does need to run on Windows, so we should support it. It'll also help adoption of Spack, as we saw in the previous slide that you can't see. Users were requesting it. They were not integrating Spack into their internal workflows because there's one platform that doesn't support it, and why would you use a solution that you can't just deploy on a CI system and not have to think about too much per platform configuration? And then the final reason is kind of industry adoption, right? Like a lot of corporate environments are very Windows-y, and they prefer that kind of vendored system. And so enhancing industry, the adoption of more industrial and more corporate environments is very important with respect to having Windows support. We also, let's try unplugging this. That is an option. Oh, it's doing something. Todd just had to get up. Todd was sitting on the cable.
If you send me a link, next time, because then you will switch the mic.
All right. So that's kind of the Spack side motivation for why do we want to support Windows. The Windows side motivation is this is a good example of the Windows package management landscape. It's a desert. There are definitely solutions out there. That being said, if you are trying to do scientific development or any kind of complex development that involves more than 10, 15 dependencies, they're not Spack. I've worked with most other Windows package managers, and they're great. That being said, if you're trying to install something that uses MPI, good luck. VC package actually handles that quite well. but it doesn't handle things like ParaView and VTK exceptionally well, and different graphics libraries and all that stuff. They're not Spack. Spack, I mean, I've been doing Windows development for a very long time, and Spack is the most convenient, flexible solution for both building and deploying packages on Windows. I've spent tens to hundreds of hours fiddling with package dependencies that were solved, like that package stack was solved by Spack in 20 minutes and then like a 4-hour build. The 4-hour build is Windows' fault. The file system is unbelievably slow, if you're not familiar. Yeah, there's far less in-the-weeds capabilities than Spack. They really don't manage complex dependency stacks well. Sometimes you have R-pathing, well, the lack of R-pathing issues. Sometimes you get binaries that don't really work for your architecture or system. Microarchitectures are less important for Windows, but they're still relevant. Things like that. And especially as we move toward these absurd AI stacks that have Python and C++ dependencies and all this interoperability, Spack is the path forward as I see it. And I think most AI developers that do anything on Windows would definitely agree. If your stack moves anything outside of Python, you need something more complicated. You need a solver, basically, to do that. And Spack is the only package manager on Windows that has a solver. And even as a more general purpose package manager, Spack actually has more useful packages. They might not all work yet on Windows, but Spack does have them in the code base and soon to be in a separate package repo. And I will say, the other package managers are also smaller. So for example, Conan is about half the size of Spack. It has fewer contributors, it has fewer stars, et cetera. VC package is similar. Basically, Spack is a huge project, thanks to all of you. And we can bring all of that, years of thousands of developers of robustness to Windows, which is pretty exciting. All right. Moving on to a little history lesson. Our initial Spack on Windows support was merged in PR 27021, which is a number I have memorized. Peter, I should probably take a moment to thank Peter. I've merged like 300 or something, or Windows has merged like 300 something PRs into Windows support. Peter's reviewed, I did the math the other day, Peter's reviewed 97.8 of them. That's a huge effort by one person. So yeah, thank you so much, Peter, for basically supporting this entire thing single-handedly. So this was the first branch. It was created in September of 2021, merged in March of 2022. We had 5,000 lines of change, which is kind of shocking for porting all of Spack to just Windows. And we rebased it every Monday. So from 9:30 to 11 a.m. every morning on Monday, that was my life. We added shell support for PowerShell and CMD. If you ask me what the difference between those two PowerShells is, I will say the version, because that's it. We added a compiler, MSVC. We now have Intel as well. We ported all of the essential core Spack features that are required to build software. We added some build system support, CMake and Ninja. NMake and MS Build would come, but they came later. We also added some conflicts with Windows incompatible parts of Spack, so anything using auto tools, GCC, et cetera. Basically anything that you look at and go, yeah, that's never going to run on Windows. And we also created an MSI installer for Spack, so it can be deployed on Windows a little bit easier. We've kind of since abandoned that in favor of other options. We're looking forward to the pip installable Spack, but we did have that initially. As I said, so far over 300 PRs merged. Peter has reviewed roughly 97% of them. Thanks again, Peter. We officially closed the 2 Windows support requests May of 2024, which is when we added GitLab CI support for Windows, and it was considered stable. And basically at that point, all of Spack's core features were stable and functional. I say mostly because we don't really support containers super well yet. So if you're looking for containerized builds on Windows, that's coming, but post Spack 1.0. And so what's left for Spack on Windows, right? Essentially we have parity with all core facets of Spack. What we're lacking is essentially packages, right? Spack has like 8,000 packages. I'm one person, so I've ported maybe 100 or so. So that only leaves 7,900 more. So we have a couple packages left to go. But outside of specific package support, Spack on Windows is ready to go for production use. So just to kind of talk about what it was like to port Spack to Windows. Initially, Spack was very Unix-y. The Unix path separator .join is how I'd say 40% of paths in Spack were constructed in 2021. So all of that had to go. In general, Spack's and path handling had to be overhauled quite a bit. And we're actually currently working on an effort to convert all of that to pathlib. So it'll get even better. No more os.path.join. Symlinks. Those don't work out of the box on Windows. You have to be an admin and enable them. So we had to work around the lack of symlinks, which Spack uses very heavily in views and the build cache and many other places. File descriptor handling does not work the same way on Windows as it does on Unix. So logging on Spack, with the nice build log Spack produces, basically all of the logs Spack produces, we had to completely fork the functionality over to Windows. There's a completely disparate module for it in Python, in the Spack's Python. Basically, we had to completely retool that approach. Windows, by default, has a 260-character path limit, meaning ParaView, if you extract it in a directory that's not C/A, will fail to extract. Yep. In order to work around that, you have to be an admin, and even then, if you're interacting with the Win32 API, that limit is still 260 characters. So you might be able to extract ParaView, but you can't use the API to build it. So we had to work around that. We had to use, basically Windows has a concept called 8.3 file names, or short paths, which is just this it's a MS-DOS 80s holdover functionality. Those of you who are familiar with that kind of framework. Basically shortens all the paths, so we kind of hacked that into Spack. So if you're using Spack on Windows and you see a bunch of weird looking paths, that's why. It's because they're really long. Upgradable locks, Windows doesn't have that. So Spack at the moment actually can't do locking on Windows. We just punted that until later, and later has not come yet. For detection, not everything's on the path on Windows. Linux, pretty much everything you're interested in is in some kind of standardized system path. Windows, as I'm sure Bill will tell you, nothing should be in the path, which is true. I mean, you get all these sort of obnoxious dependency resolution issues, and I just fielded a CMake issue like a day ago. Someone's like, I installed 4.0.1, but when I run it, it's still 31.5 or whatever. And it's like, oh, it's because it's too soon in your path. And then basically, Spack assumed there were rules to an operating system, right? It assumed there was kind of like structure. Right, so we had to kind of work around Spack's assumptions that there were things like tar or file or basic utilities available natively on the file system. Windows, to their credit, did eventually add tar natively, like halfway through this effort. But when we started, there was no native tar on Windows. Also, just spec queries on this command line, neither of those work due to Windows command line parsing issues. Anything with an up caret or an equal sign or most of spec syntax does not work natively on Windows. So we had to work around that. With kind of fancy quoting and parsing and all that stuff. And then Spack also assumed the OS versions aren't going to change weekly. If you're familiar with Windows, you're familiar with forced updates at least twice a month. And when Windows does that, it changes the build revision number, which changes Spack's conception of the operating system number. So all those binaries you built last week, you can't reuse them because they were built for a different operating system. So we had to work around that as well. So what did we do to work around these things? Well, first, we had to spin up an MSVC environment. If you're familiar with MSVC, you need to invoke VCVARs, the perennial pain of finding where VCVARs is. Well, now if you're using Spack on Windows, you don't need to know. Spack knows, as long as it can find MSVC, which it can. All you need to do is, if you're running a Spack install, it'll do it automatically. If you want it for yourself, for like a Spack develop command, Spack develop will do it, or Spack build env will handle that. Runtime DLL handling, right? Windows doesn't have R paths, doesn't have loader paths. If your DLL is not in the directory the executable you're running is in, or another DLL is in, or on the path, which means it's vulnerable to system visibility, Windows can't find your DLL. So we had to work around that. Basically, we just shim every DLL your executable or other DLL depends on into the base directory, into like the bin of your installation. We have some improved support for that coming actually probably next week. For Fortran, we went with one API as our Fortran provider. It vendors native Visual Studio integration, so setup is incredibly easy and seamless. We added some registry interaction for detecting packages, handling Visual Studio installs, registering Spack packages, stuff like that. And then we also, of course, had to pretty much partially overhaul compiler and external detection to add Windows-specific paths and things of that nature. And then we also had to add path handling. Yeah, there's a kind of a long list of things Windows had to work around to, or add to support Spack. So file system, completely different. No, like I said before, no locking, no symlinks. Windows can do symlinks, so we basically just have a series of fallbacks to try to use system symlinks, junctions, hard links, et cetera. Junctions don't work for files, they only work for directories, so it's not even a great fallback. And then eventually we do fall back to a copy, which is unfortunate, but Windows. We added support for build caches. We overhauled logging. We added some Windows-specific build systems and make an MS build. And then we added support for the Windows drivers. Added some MPI providers, MS MPI. Coming soon will be Intel MPI. File and GPG, which are critical to our build cache, can't be built directly on Windows. So we had to create a unique bootstrapping mechanism to acquire them. Basically, we build them using Spack-owned infrastructure and a Docker image in a different repo. And then we added 2 Spack packages that are Win, GPG, and File to acquire those during the bootstrap phase so we can actually use them. Basically, they're just cross-compiled on I think it's a Fedora Docker image using the MinGW cross-compiler. We created build environments for MSVC, and then we also took a lot of care to ensure our OneAPI, MSVC, and all the driver versions played nicely together. If you're even one version off for any of those, your builds can get very wonky and fail very bizarrely. So that was a bit of consideration we took. And so moving on, how do I use this, right? Basically use it the same way on every other platform. They're currently external only, for MSVC and OneAPI. But outside of that, Spack install the package, it'll just work. You can use it with Visual Studio or VS Code directly on the command line. And then how do we port existing packages? Basically, you identify a Windows-compatible build system. CMake is easy. It's already cross-platform. You don't have to do anything. Otherwise, you find your MS build and makefile, et cetera. Create a Spack builder for that. So instead of just having a Spack package, you basically have to use the new builder framework on Windows. And then you just ensure that there's basic MSVC compatibility for the package. Determine a default configuration. I find it's easiest to just go visit that package's CI and see how they're building on Windows, and then just copy that directly into a Spack package file. Determine available variants for the platform. Pick is never going to be one of them, just a heads up. And then you'll typically determine that by manually inspecting some build system, and then you'll translate the build arguments. So our roadmap. Compiler wrappers, basically we have hacked the Windows linker to inject absolute paths to our dependent DLLs, so using a little undocumented part of Microsoft's linker behavior that Brad King found, so credit to him for that. So we won't have to use the symlink hack anymore. We'll have these directly injected into our binaries. That should be landing sometime next week, depending on how busy Peter and I are. We'll have significantly more robust OneAPI support, including installable OneAPI. We'll have more stable MPI pair view support. We'll have some proper ABI-based binary compatibility, and we'll have concretization caching, which isn't Windows-specific, but it is cool. And then so beyond, we'll have some Unix-style build contexts, Spack-driven Visual Studio installations, .NET support, and all sorts of other goodies. And most importantly, we'll have more packages. That's pretty critical. But I believe I'm at time, so
yes.
That is my last slide.
OK. Thanks, John. All right, I think we have time for a question or two while Ryan gets set up. So, any questions? OK. Let's
Ryan, do you want to use the other adapter? Because this one kind of sucks.
OK, so thank you. That's kind of an enormous amount of work you had to do. And so I just had a comment/question. So you mentioned GCC not being harder and only preferring MSVC. And so R has had, they have a Windows distribution. They've been bundling GCC, I think, since the 90s. And so I have a project that I'm going to talk about tomorrow that entirely depends on needing to use GCC on Windows with Spack. And I was wondering, do I have to grovel with Bill Hoffman to try and get this possibility of GCC supported with Spack on Windows, or Todd, or is this a possibility?
That's in the roadmap. When I said the POSIX compliant Spack build environment on Windows, that's building native Windows binaries on Windows using GCC or what have you. Basically, whatever POSIX compiler you want to use. So it's already on our roadmap for, I think, I'm targeting that for September. Don't give me a hard deadline on that one, but roughly.
One more question from Mike.
So as I understand it, the real impediment to broad adoption is the lack of products that build on Windows. Is that a correct statement?
It's not even lack of products, it's just lack of available time to port the package recipes.
Can you get some help from the package teams? I mean, have you tried to put out like a call for activity and maybe have a dashboard that says which products have been moved over? And I don't know, it's just an idea. Maybe ask us to help you.
Yeah, that would be fantastic. We had a CDAC dashboard of the functional projects in Windows for a while, but it kind of fell out of use. But yeah, any help is
Well, we do have, so Ryan's going to talk about CI, but we do have a Windows stack in CI. And in fact, like people could work collaboratively on that to get those builds working all the time and to keep them working. So we've got that option. So yeah, let's try to get some support. Okay, so let's thank John one more time.